Hello everyone, I'm Michalis Kamborelis and welcome to the latest movie about Castle Game Engine. We haven't made a new video for quite some time and I want to change it. I'm changing it right now. So this video is going to be like the recap, the summary of the latest developments going on in Castle Game Engine, the things that we have done lately and the things that we are working on right now. So we are going to announce them as new features very soon. Let's jump in. Okay, so just basically a short recap, like give me a few minutes to if you're new to Castle Game Engine, what is this? So we are a cross-platform game engine. It means that you can make games or three-dimensional or two-dimensional visualizations, applications. You can make them for a number of platforms using the same source code. You can recompile your game for a number of platforms, and this includes desktop, that's Linux, Windows, macOS, FreeBSD, that's mobile, Android, iOS, that's console, that's Nintendo Switch, and then also the web, Target, which is actually our new feature that I'm going to talk about in a second in more detail. We have a kind of powerful visual editor, which means that everything that you're doing can be visually designed. Let me actually, this is our editor, let me create a new project, new three-dimensional project, new one, a new name. So I can enter and I can edit a view of my project, okay? And here I can navigate, this is the design time view of my project, and I can move things around, I can configure things, I can configure the lights that are present in my scene, and well, I can generally do most of the things that you would expect are possible to be done in a three-dimensional or two-dimensional game editor. Okay, so this is a short example. As you saw, I was talking and doing some nonsense. Yeah. Now, once you have designed your thing, everything that you see here on the left side is actually a component, which means that it's an instance of a class in your source code. And everything that you see on the right side is a property. It's a property of a class, which again, what I'm saying is that everything you see here, everything you have designed visually, you can also control it from code. And we use Modern Object Pascal for our source code. You can compile using Free Pascal or Delphi. And yeah, let's actually open a project here. If I will open a project, I can open a project in Delphi, Lazarus, or in VS Code, or actually in another text editor you would like to open it, Pascal code. You don't need anything special. We do have, however, a special integration actually for VS Code, which is kind of cool. So let me show it here. So let me just open the project in Code Editor. And this is the Visual Studio Code showing me our code, and I can basically go ahead and I can edit something in our code. For example, this is the view, and here I can configure when the enemies are initialized and how the enemies actually move. And for example, what happens if I press here the left mouse button. Here you can see that there are instructions saying that if the user presses the left mouse button, then we should shoot. And also we should make a sound, shoot. And also we should check whether we have actually hit something, and if we have hit an enemy, then the enemy is going to be actually hurt. And we can also toggle the mouse to hit the right mouse button. So this is the source code, yeah? Edit it, yeah? Go ahead and edit here and implement here any game mechanic you would like to. When we press play in the editor, then the game gets compiled. It is compiled right now with the Free Pascal compiler for Linux, which is the platform I'm working on right now. Let me just turn off the sound. And to turn off the sound in this case, let's just go ahead and here's sound engine enabled, false. Yeah, and that's good enough for us for the simple demo. Okay, no sound. And now I'm playing the game, and as you can see, the game actually contains some kind of a stupid ad hoc modifications that I've done to this game when we have been talking. And I can, when I press with the right mouse button, I'm entering the mouse look mode, which means that when I rotate my mouse, then when I move my mouse, then the view rotates. And if I press with the left mouse button, then I'm shooting. Okay, I can actually shoot those guys, and this guy is floating in the air just because I moved him up when I was editing the example and talking a minute ago. So that's a really short overview of Castle Game Engine. I won't go here in more details. You can find more details, more introductory videos about Castle Game Engine on our YouTube channel and of course on our website. You can go castle-engine.io. We can have here everything essentially. In particular, we link to the latest and best video tutorial here, and we have a text tutorial if you prefer to read here, and we have a number of documentation here, and you can read everything about installing, using the engine for two-dimensional, three-dimensional games, how to code using Pascal, how to design things using the editor, how to extend the editor, and well, do a lot of other fun things. So that was the short introduction to Castle Game Engine. As I said, go to other videos if you want to get more introductory videos about Castle Game Engine. Now, jumping into the promised latest developments, so the latest things that we have been doing in Castle Game Engine. So one thing, I think kind of a big thing, is that we have introduced the web target. And the web target, as they say, this is in development now, but we have already kind of some promising results, so I want to share them with you. So I already made some posts about how we have some initial results. Now then we have extended them to allow user interface and two-dimensional games, and then finally three-dimensional games to actually work smoothly on the web. So let me just actually run some latest demos that we have actually compiled for the web. So this is the example from the engine. I mean, it doesn't have any code that is actually specific for the web. We have developed this example just to use it on Windows, Linux, and on the regular platforms, but now we can just recompile it for the web. And once it's recompiled, we can just put it on the web, which means that it's just part of a web page. And as you can see, I just opened it in Firefox, and it also works in Chrome-based browsers, Vivaldi and so on. And it works just like the same game would work on the desktop. Yeah, on the Linux or Windows, and this is the game that I can play, and this is the game playing in the browser. Now I can also actually open this game and see how this game looks like in the editor. So examples, I will be holder, and here I'm opening the project, yeah, and this is what we have been actually playing with in the web a few seconds ago. Yes, so I can move things around here, and this is the actual project where I have implemented some very simple walking logic, and yeah, I can basically have fun with it. Yeah, if I would like to run it on the web, well, the only thing I really need to do, I mean, okay, two things. Okay, so one thing is I need to install some prerequisites, which means that I need to have installed the compiler that allows us to do everything and allows us in particular to build our game for the web. We actually use two pieces here. We use Pass2.js, I mean, developed by actually very similar, or actually the same people, yeah? So one thing is the Pass2.js, and this is the transpiler actually, so it converts Pascal code to the JavaScript code, and this creates part of the application that you later put on the web, and the major part of the application is actually compiled using the free Pascal compiler with the WebAssembly support. We have here the instructions how to install it yourself. You can try everything I'm showing here yourself. It's open source, free. Go ahead, check it out right now after the video. So yeah, so you can try everything yourself. And the thing is that you have to install those compilers, and once you have them running, then the only thing you really have to do is you go to the run, change the platform to the web, and then you press play, and there you will get the application that you want to have. Let me actually prove it, yeah, because it's not. I want to show that it actually works, and I also want to show you how it actually looks like when you generate an application for the web. Okay, so now we have started compilation of this application for the web, and as you saw, the only thing I did in the editor was change the platform, and then I hit run, yeah, and then I wait. Yeah? So that's really everything I need to do. The game will compile everything. I mean, the editor now runs our build tool, and our build tool runs the pass2.js and then free Pascal compiler for the WebAssembly, and then it also places some HTML files like generated from the templates in our engine. You will see the output in a few seconds when it finishes. And yeah, I don't need to do anything. I mean, I can keep talking, yeah, but I don't need to do anything else. My hands are here. So I'm just waiting until the compilation finishes, and at the end I will have ready HTML plus the WebAssembly file plus the JavaScript file, and I can just open it in the web browser. We will also actually run an HTTP server to serve those files to be easy opened in Firefox, in Chrome, in everywhere. And yeah, I just need to wait, and then I can also, of course, once it finishes, I will show you how I can actually go ahead and just edit the things that have been generated, and in particular I can edit the HTML file that is going to be generated. The HTML file is just an example. You can put the generated thing here as part of your web page. Anywhere. You can surround it with any content, with any style you want. The only thing we require is that you have a canvas with a specific ID, and that you add a few lines that describe, that link your HTML code to our JavaScript code, and then our JavaScript code like is doing the rest. Yeah, it's loading the WebAssembly file, and it's downloading the data, and it's doing everything else necessary. Okay, so let's wait until this finishes. Okay, and there you have it, yeah? So you just saw everything. I mean, you saw it online a few minutes ago, but now it's all running on my computer. I really just compiled it, it's really just running now. And let's actually check it, okay? Because I've done some stupid modifications to the design. Yeah, they are, okay? So this is now in the middle of the screen, and it doesn't make any sense, yeah? But as you can see, like, it actually compiled what I was editing a second ago, yeah? And I can play this game. Here I have the log of my game. The log, of course, I can control this log from my Pascal code. I just write return log. I just use those. I use our usual logging facility, which means I'm just using those trivial instructions, and they send messages to the log. The log on the web is displayed here at the bottom. You can, of course, hide it also for the actual production application. The log is also visible in your console. Developer log, this is the Firefox, so I just press F12, and in Chrome it's also F12 actually, just some UI of the developer tools looks a bit different. So I have the console in Firefox under F12, and I can just inspect the log of my applications, and this log is generated by our Pascal code. As you can see, there are also some to-dos here, yeah, but yeah, everything basically you can generate those messages yourself to debug what's happening in your code. And I can also make myself full screen, okay? So I'm actually going to do it, yeah, okay? I mean, my camera is still on top, but otherwise, like, the window is actually full screen. And I mean, it's the same thing. I mean, our UI scaling actually took care to make sure that the UI has still, like, well, it has been scaled. To be larger, of course, to fill my whole screen, my whole monitor, but it also has been scaled preserving the aspect ratio. Long story short, we have the UI scaling algorithm, kind of similar to what Unity is doing, so it's not that revolutionary. And this makes sure that what we do is actually, it looks sensible regardless of your screen resolution in pixels, regardless of your device size. Alright, so that's our game, yeah, running on the web, and yeah, I just pressed play. so nothing, I didn't have to do anything special to actually make it happen. Let me just do one more thing, which is let's actually take a peek under the hood. How does it look like, okay? So the web server that we have run is actually just serving this directory, okay? So it's the subdirectory of our project, castle-engine-output/web/dist, like distribute, okay? So this is the directory that you want to serve on your web server. And as you can see, I mean, it has a few files. This one is really the most important file, and we can optimize it, we can make it smaller, don't worry. It's just the debug build of the game is larger. So it has like 16 megabytes, I think, when I'm generating the optimized version. And this is the JavaScript file. So those are the things you just have to carry, okay? Okay, you're not supposed to modify them. You just have to place them on your website. Here is the data of your game. It's just a zip, and right now it's actually good enough. We don't need anything more complicated here to hold the data of our game. And so when you open the HTML of your game, the HTML is loading the JavaScript, and the JavaScript is loading the WebAssembly and the zip with the data, and then the WebAssembly is actually extracting the data files from the zip. You don't need to know anything I just said, okay? Forget about it. You don't need to know it. The thing that you may and want to know is that you can edit the HTML file that I'm pointing out, okay? So it's really, as I emphasize, like just the regular HTML file, and so it's here, it's really just a regular HTML file. It has a link to our JavaScript file, and then it has some CSS style which we are completely free to edit, and it has some progress bar and loading information which we are free to even remove. Our code is prepared to like work without them. And the only thing really important is that you need to have a canvas, and this canvas must have an ID of Castle Canvas, okay? And this is the really almost only thing we require. Everything else is up to you, okay? You can modify it. By default, this template is using Bootstrap because it was just a nice way of getting a nice looking buttons and everything. But you don't need to use Bootstrap. You don't need to use anything special here. Essentially, you can just place it as part of your website, and as I emphasize, add any style, add any content around this. It's just a web page, yeah? So, the things that we have done lately here, one of those things is that we have actually employed we are using the binary N, and in particular we're using the WebAssembly optimization tool from this package. So if you install this optional package on your computer, then it's actually kind of cool because it's going to optimize your build, and it's optimizing the size of your build, which is making it more or less 1/3 smaller. So like from 43 megabytes in this example to 14 megabytes in this example. It's also making your build load much faster, also because it's smaller. And also it's making your build, your game actually run faster. So the WebAssembly optimizer is they just implemented a number of WebAssembly specific optimization, and a big thank you for Michael Van Caney for pointing me to this tool, and we now use it automatically. If you have this tool installed, then actually our build tool, Castle Game Engine, when you build the release version of your game, which you can do by toggling here the run to release mode. So once I'm toggling this to the release mode, and if I will do the build again, then the next build will automatically invoke this WebAssembly optimizer, and it's way cool, okay? It's making everything better and smaller and faster. So that's one thing we have done. More things we have done is we have actually improved the three-dimensional shaders. We still have some to-dos there, for example, to make the bump mapping actually work correctly, but it's better. You can actually display some three-dimensional games as you saw right now. Let me actually run some demos aside from the one that we have already seen. So for example, this is the creature behaviors demos, and this shows our automatic components that allow you to have very easy game logic, enemy logic in your game. So you can have a player that is something living, and that is the enemy of other characters in your games, and those characters can track the enemy and they can try to kill the enemy. In this case, they will try to kill me with a sword. And so this is like, actually you can click it, you can click around the editor to make this logic happen, and this is the result, okay? So we have some skeletons that are now trying to kill me, and as you can see here, more skeletons are actually getting to notice me, and more of them are trying to kill me. Let me just run away and actually let me start shooting, okay? So I can shoot at them, oops, not with the space on the web, so I can shoot at them and I can like, well, make something interesting happen in the game, okay? So this was a very simple game using Castle Game Engine, and a very quick game using Castle Game Engine. Now it works on the web in Firefox, and yeah. Some more demos. So we have the Castle Model Viewer, which is like the mobile, but in this case also the web version of our model viewer. We have Castle Model Viewer is one of our applications done using Castle Game Engine. Even if you're not interested in like using the engine to develop your own games, you can use our model viewer to inspect your 3-dimensional and 2-dimensional models. And we support a number of formats, just like Castle Game Engine. So GLTF, X3D, VRML, Spine JSON. The IFC is also the new format that we support here. So yeah, we support a number of 3-dimensional formats, and this viewer has also the mobile version right now on Android, though we plan to make soon also an iOS version. And then this is the version of this viewer on the web. So we also can open, I mean not yet open, but we will be able to open arbitrary 3-dimensional models on the web. Here you can toggle between a few already provided models with this application. The actual loading of external models from the disk doesn't yet work. It's going to work soon. It's a work in progress. But yeah, what works already is that you can browse the existing models like packaged in the data of this application. So for example, here's some dungeon where I can walk, and I have those things where I can walk. I mean like gamepads, joysticks essentially. One of them allows me to rotate, the other allows me to move. But I can also move using the AWSD keys, the arrow keys, and then I can just rotate by dragging with my mouse around. So it's a mobile application. It also makes sense on the web. And finally, I wanted to actually show you one other application that I've done lately for the Blaise Pascal magazine, for that leftover big. And this is kind of a cool thing. It's here available for the web, but it's also available on desktop, Linux and Windows. It's kind of a fun application because you can throw a dice, and the dice is getting thrown using physics. So it kind of looks different every time and looks hopefully kind of natural when you throw it. But also the result of the throw is actually known beforehand. How do we do it? We actually run the physics simulation before we show it, and then after we know already how the physics simulation will look like, we actually rotate the dice. Well, you can think that we're rotating the texture. That's an approximation of what we do. So let's say that we are rotating the texture on the dice to make it such that the desired outcome is at the top of the dice when it lands. So for example, let's say that I always want to have 6. Okay, 6. It's always going to be 6. Yeah, 6 every time. 6 every time. So that's just a fun application now available on the web. You can have the dice looking in various interesting ways. Okay. So those are like the new 3-dimensional demos of our engine. We have also improved the anisotropic filtering of our how the anisotropic filtering of textures work on the web. We had some problems with it before. Now they are fixed. We also introduced a new way to embed fonts in our applications. It's made on the web. It's not perfect. We are going to actually change a little bit how we manage fonts to make it really good on the web and also on the other platforms, so that you don't need to distribute free type library, but you can still have custom fonts like from TTF or OTF or WOF files rendered in your applications. Well, right now it's kind of an in progress way. It actually works, but has a number of drawbacks. You can scroll down here to the plans and to-dos, and you can read all the like gory details, like okay, what do we have and how it's bad, yeah? But it's bad, but it also kind of works already. And you can actually see it working. For example, when I go here to the user interface component gallery demo, and again I emphasize this is a regular Castle Game Engine demo. We haven't made it for the web, okay? It's a demo that you can run on any system, and you can explore it, of course, in the Castle Game Engine editor. Okay, so this is the demo here, this is the main view, and you can explore here a number of pages that are available here, like this. So this is the view in Castle Game Engine editor. Now in Firefox, well, the same thing, yeah, and looks sensible, of course. And that's the point. Yeah. Here are our checkboxes. Here's an edit. I can actually type something, and here are some groups, some layouts, some scroll bars. Okay, so I can do things like this. I can display simple shapes. I also wanted to show a button that actually contains an animated scene inside, because we can do it, and that's kind of cool. So this is the demo of our custom components, and I did want to mention here that this different font, okay, this small thing, this is actually using a custom font loaded from the TTF true type font file, and here it's working on the web. So it's working as advertised. But as I say, internally, if you know where to look, there are some problems. We're going to improve them. Okay, so that was a short overview of our new web target. And this is, to be clear, like, I mean, as you saw, it works, it's cool, but there's also some things that I would like to make, to improve here, to make it better. So stay tuned for more information about this. So another thing I wanted to talk about is our new support for the new three-dimensional model format, which is the IFC. So the web page describing all of this is castle-engine.io/IFC. Now IFC is a three-dimensional model format, so another model format we support, but this model format is very popular among the building information industry, building information modeling. Sorry, but also industry. So this three-dimensional model is commonly used to actually express like real-world things that are going to be built, like buildings or like windows. We actually have made it. This part of this work is being sponsored by a company that is making actual windows. We're not shy about it. Thank you very much. So this model format can be used to design actual things, and it is actually used to design actual things. There are applications like FreeCAD and Bonsai Beam, which is like a plugin inside the Blender that allow you to actually load and save models in this format. And now you can also load and save models in this format using Castle Game Engine, which means that Castle Game Engine can interoperate with FreeCAD, and it can interoperate with the Bonsai Beam, and essentially you can design things in Blender using Bonsai Beam, and you can see how it looks in Castle Game Engine. So now I have just actually just opened the Blender file, and if I just create a new project using the Bonsai Beam, which is the plugin in Blender to read and write the IFC files, let me enable it here. Okay, now it's enabled, and as you can see, like, the UI of Blender has changed a little bit. Okay, so for example, here you have some additional information, like actually a completely new UI inside Blender that allows you to manage your IFC project. Let's create a new project, although, well, we already have a new project, but the new one actually will contain the new site and new building and new story, which is like a floor essentially. And there we can place things. For example, I can place a slab, which is essentially a floor, and I can place it in my model. Okay, so that's how it looks like. Now, when I go into the edit mode of this floor, I mean, I'm kind of constrained. It's not a mesh for Blender. It's something much more constrained, and it's going to be generated as an extrusion with a specific height. Well, yeah, but I can edit it in Blender, and I can also actually add here some, well, free objects in Blender. For example, if I go here, I can press Add, Mesh, and I can say that, for example, I want to add cylinder, okay? And I want to say that the cylinder, I want to scale it like this, I want to scale it like this, and I want to say that, okay, like this cylinder, let's apply the scale. I want to say that this, because the IFC format doesn't support scaling in all cases, because scaling is not something that you do in reality, right? When you make the real things, you cannot bend them arbitrarily or squeeze them arbitrarily. So it makes sense, yeah, that when you make real world things, the scaling is not an operator that you can use as flexibly as we are maybe used to using it in games. So I have made now a cylinder in Blender, okay? It doesn't mean yet anything in for the IFC standard, but for example, I can say that I want It's to say that those columns, they are actually columns. I mean, they have the meaning of a column, so they support additional floor. They have the meaning of a column for the construction guys, girls that make this building. So this is an actual column that is supposed to support the additional floor of this building. And how do I do it? I go here and I say assign the IFC class. In this case I would say the IFC element, and the class of the IFC element is going to be IFC column. Where's the column? Here's the column. Okay, so I'm assigning the class here, and I can just kind of repeat it for those other columns. Okay, now this isn't really something, I mean, you don't need the IFC format, of course, to express something like something as simple like this. You can also export it to the GLTF or X3D, but the point here is that exporting it to the IFC, it actually allows you to, as I said, interoperate with other applications like FreeCAD. So let's save it now. I mean, because now in Blender, yeah, I'm not even showing Castle Game Engine. Let's show that it all actually works in Castle Game Engine and then in FreeCAD. Okay, so blah blah dot IFC. Let me actually save it as IFC JSON because this is the format that Castle Game Engine can handle. Let me also actually save it as the regular IFC file in the step encoding because this is something that the FreeCAD can handle, but no worries, there are some conversion applications between the step encoding and the JSON encoding of the IFC files, and I just went into details that I probably shouldn't maybe go into at this point, but the thing is that when you encode the IFC file, when you save it to disk, there are a number of encodings, a number of ways how to do it. One is the JSON, this is that we support in Castle Game Engine, and another is step encoding, which is commonly used, and it's, for example, the only encoding available in FreeCAD. And no worries, they are interchangeable, I mean, and there are conversion applications, and we point actually to one of them from our page that you can convert between the step encoding and the JSON encoding. So it's really not a problem. And again, it's a detail that I didn't really wanted to go into much detail here in this hopefully still short introduction about the latest summary of the latest developments of Castle Game Engine. But here you go. So I just made a model in Blender, yeah, and I'm still not actually showing what it means in Castle Game Engine. But at Castle Game Engine, it means that I can just run our in Castle Game Engine, it means that I can just run our model viewer application. So let's go ahead and actually just run it. From here it's going to be simplest. And I'm just going to click open. And there we go. We have the same application here. Okay? And we can also go ahead and we can open it in FreeCAD. And it's going to show us the same thing. Open, open. Where's my desktop? There we go. There we go. Now there we go. Yes, and it shows us exactly the same thing. Okay. Now this is of course not everything that we actually support here, because the point is that it's not just a three-dimensional model. I mean, you can actually do more things with it in Castle Game Engine. How? Well, let's open our example. Let's open our example called the examples/IFC, and here you can see that this example allows you to not only open but also edit the IFC files. Like in the application, in Castle Game Engine, you can actually work with those IFC concepts, like columns, like slabs, which are floors. You can actually modify those objects and you can save them back to the IFC file. Which means that you not only can load IFC models, you can also manipulate them, and your application can kind of think in the same terms as the IFC specification, and then you can save them back and open them again in Bonsai Beam, FreeCAD, or in some big commercial applications like ArchiCAD and Revit, which I don't have installed. I don't have them, but I understand that they are actually commonly used by people working professionally in this domain. So you can now interchange your Castle Game Engine things, load and save, with those big commercial applications and with those big open source applications too. So this is our example, like our IFC demo essentially, and here you can just add some very simple looking things, yeah, like this is a symbol essentially of a wall and of a window inside the wall, okay, and it doesn't look like anything very much impressive. Yeah, but here you can actually see that what you're doing here in Castle Game Engine, it actually corresponds to the IFC concepts like wall and so on. And to make this demo complete, of course, here we can also open this IFC demo that we have made. And as you can see here, the column cylinder, it's actually a column. So in Castle Game Engine, it's still a class IFC column. So you have 4 columns called cylinder, and you have 2 floors, because I made such a silly thing in Blender with 2 floors like this, okay? And here's some additional demo, because I feel that when I first recorded it, I didn't really do it justice. So this is actually the improved version of this model in Blender. I mean, like 5 minutes more improved, but it's much better, as you can see. And we still have those columns, yeah? And we also have 2 stories, so like 2 floors of our building. So I have exported it to an IFC model, as you have seen before, and now let me again like load it into our application, into our Castle Game Engine application, and there you go, okay? So it still looks sensible, and the one thing that I should have shown, and now I'm showing it, is that you can also edit the model in Castle Game Engine. So this is the way how you just edit the model. You just drag around those transformations, and you can drag around the roof, the column, anything you want to. And you are actually modifying the IFC classes. You are actually changing the transformation of the IFC column. And as you can see, the IFC column here is represented in the sidebar. It's part of the IFC building story. So it's like part of a floor of your building. And here you have the second floor of your building that contains the roof. So the Castle Game Engine, and in particular this application, this example / IFC, it can serve as an editor for the IFC model format, and you can basically then edit your model anywhere you want. In Bonsai Beam, in FreeCAD, in Castle Game Engine, all those applications can load and save IFC files, and what is really most important here, all those applications kind of think in terms of the IFC classes. This is something that is commonly known as the native IFC in the IFC community, yes, and now we have a native IFC essentially in Castle Game Engine. So this webpage that is linked in the YouTube video description is kind of actually full of examples. I mean, the Pascal code examples, how it actually looks like in Pascal. But the short version is, well, the short version is really short, which is that you can just, if you want to, for example, have an IFC wall, well, then you have a Pascal class called TIFC wall. You create an instance of this class, and then you have a new wall. You can add a representation of a wall, which describes how the wall looks like and where is this wall positioned in your world, and then you add this wall to the IFC model, and then you do whatever you want. Here this example shows that you can update the display of this IFC file, which underneath generates the X3D nodes graph. And this is something that is actually getting displayed by Castle Game Engine, but you essentially don't need to care about it. The point is that you have modified your IFC model, and then in the end you can display the new IFC model, and you can also save it, and this is all described on this web page. Now, additional things about the IFC is that we have also, we have a number of test models. If you go to our Castle Engine / demo models, then there's a subdirectory IFC, which contains a number of test IFC models in the IFC format. Some of them have been created using Blender, Bonsai Beam, and some of them have been extracted from the IFC specification. As you can see, you can just fire up Blender and you can create your own test models, and we encourage you to do this. And that's most of the things I wanted to mention here about the IFC support and the IFC standard. As you can see, we have a web page like filled with information about more details and more examples. And yeah, if you're working with IFC, we encourage you to try it out, try out everything mentioned on this page, but in particular try out the examples. That is, I hope, mentioned repeatedly on this page, examples/IFC. This is our demo of not only loading and showing, but also modifying the IFC files. Go ahead, give it a try, and have fun with the IFC model format. Thank you. Next thing I wanted to talk about is our new support for the zip files. So archive of files packed inside the zip. This is something that is actually used internally for packaging your data for the web, as you saw, but it's also actually a new class in Castle Game Engine that you can use yourself for any purpose. You can, just pack your data into the zip or pack anything you want for the zip, and you can read and write the zip contents. And well, this is often beneficial essentially because the zip files are so popular. So it's a very simple class that works on cross-platform, on all the platforms that we support. And it also works with all the compilers that we support, both Free Pascal and Delphi. You can open files, zip files, you can read files from the zip and also you can register the URL handler for the zip. What does it mean? It means that instead of just reading files from the zip, you can say that this zip is actually represented by a protocol, for example, my textures in this case. And then everything, like every other part of Castle Game Engine, can automatically read the data from your zip. For example, if I open a texture from this URL, then I'm actually accessing a file inside the zip. And that's a nice thing about our zip supports. So it offers you reading and writing on all the compilers, all the platforms, and it's also integrated with the Castle Game Engine idea of the URLs to represent anything you want. And there's a simple demo about it, and it's called Custom URL Handler. This demo has existed before, but now it's kind of it's extended. Okay, let me just open it. So you can go ahead at the code and take a look how does it work. So in the simple version, when we use the tcastle zip class, we open a zip like this, and then we register the protocol of the zip, and then we can access everything using the URL like my packed data. So for example, if I will open my packed data blah blah .gltf, I can do it if the gltf file was part of this zip file, and the rest of this application shows that this is actually working. So I can actually load my data from a zip, and you can actually see that in case of this example, the data of this game is here. Okay, it's just a zip. On any platform, not just on the web, on every platform. The data of this application is just a zip file, and the zip file inside it contains some very, very simple three-dimensional models and a very, very simple texture. It's just a demo. And the point here is that now you can use the tcastle zip class to actually open the zip at runtime and use data from it just as if it was not packed in the zip, because it's easy. Let me just run it. Okay, and this is our simple demo that shows that we can read the data from the zip. This is the image from the zip, this is the model from the zip. Very, very simple, just to show that it works. Go ahead and read the API documentation of this class, and they are going to be linked in the description of this YouTube video, so you can learn more about it yourself. And that's actually almost everything I want to talk about. That's not everything, but I think let's leave something for the next time, because it was supposed to be a short overview of the latest developments of our engine. So if you like what you're seeing, let me just finish with this. If you like what you see, I would very much appreciate if you support our engine. You can support us on the Patreon. If you have a company, then we are also open to a commercial cooperation with your company. We can provide support, we can provide dedicated features for your company, open source or not. So I'm open to basically supporting a Castle Game Engine used in companies in various ways. If you are interested in this, let me know. There are ways to contact me spelled out on this page, castle-engine.io/donate. And there are actually other ways if you would like to help us in the engine development. For example, you can also rate us at various places. For example, you can rate our application on Google Play, on itch.io. You can rate our Visual Studio Code example extension. It's all appreciated. And I guess, I mean, the most important thing how you can help us making this engine nice is by actually using it and telling us how do you find it, yeah? What are the good things, what are the bad things, and how can we improve? And have fun, have fun with everything I told you. And I think this short summary of our latest development is not so short in the end, so sorry about that. And stay tuned for some future movies about our engine. I hope you have enjoyed it. Thank you very much, thank you for your time. Bye bye.